Hey, my name is Johan. I'm the Director of Technologies for Spartacus Technologies. We are on a mission to empower maintenance and reliability teams, and I'm going to present to you our roadmap to reliability excellence. So it's 2024 and our societies have drastically changed for the past few years, especially since the pandemic. Remember 4 years ago, some industrial facilities were forced to shut down because of the supply chain issues or even sanitary reasons. As a result of that, lots of workers lost their jobs. Some of them decided to retire. 4 years after, we are in a situation where we have a gap in manpower and knowledge. At the same time, younger workers enter the job market, and there is also a gap in their knowledge and skills. Also, do not forget that IIoT, Industry 4.0, is entering our lives at full speed. There's also a very big gap in terms of knowledge related to these new technologies and way of doing things. Also very important to understand is that the younger generations have very different expectations than the older generation of workers, and I'm including myself in that. They want more flexible work options, they want more healthcare support, and most importantly, they want a very enjoyable workplace. And lastly, another topic that industries must face is sustainability, global warming, and energy conservation issues. The public is aware of that, our politics and our society in general is aware of that, so industries must play a role in that. So what can we do as maintenance managers and maintenance professionals? We must develop our teams. We must create a safe work environment. We must create a very enjoyable environment for all of our workers. We need to focus on sustainability, energy conservations. We need to have an environment that is less reactive. So in other words, we must aim towards reliability excellence. So I've been a reliability engineer for 10 years and I've been to dozens of industrial facilities. All of these facilities suffered the same problems and same gaps and same issues. So I've built this framework towards reliability excellence. It is a framework that companies must adapt in order to consolidate their maintenance and reliability program foundation. It is a list of steps that companies and industries and manufacturing facilities must follow to achieve reliability excellence. The first step in that roadmap is establishing a vision that is pragmatic and realistic based on the economic and society context. So if I had to lay out a vision for post-pandemic organization, I would focus on the following points: less reactivity, less incidents, and less overtime for my workers. Also, focus on sustainability and energy conservation. Make sure your operations are resilient in the event of supply chain disruption. Also, make sure your employees are proud, loyal. They want to stay with you forever. IoT, Industry 4.0, Industry 5.0 is very important, but be wise about it. Only use these new technologies on very critical pieces of equipment for your operation. Do not spread your efforts just on very important pieces of equipment. For the rest, make sure you have 100% compliance on your PMs and loop tasks. This is the foundation and this is the basics of a good maintenance and reliability program. So you've established your vision. Now what is the way forward? In order to establish a proper and realistic action plan, the first step would be to have an assessment of your current situation. There are lots of ways to do that. The first thing would be to use benchmarking. There are lots of benchmarks out there, lots of companies that can offer that. One that I like is the Solomon-Ram study. It states that the best performers, the first quartile companies, spend 3.5 less money in maintenance cost, while at the same time having 10 to 14% higher availability for their assets. So it means that they are focusing their efforts resources and money on the right thing at the right time. A very important step in doing a reliability and maintenance assessment is to look at your delays. Lots of companies I've worked with have delay tracking tools, and it's very important to look at those delays to identify the source of problems and gaps. I'm going to give you an example of a steel manufacturing company that I've worked with a few years ago. The mind state at this time was that most of the delays were coming from the maintenance people, either electrical issues or mechanical issues. After looking thoroughly at the delays, we realized that 2/3 of the loss of production or loss of availability was caused by changing and recalibration of the machines or operational errors. So that really changed the mind of the managers of this company and focused more on different things than just maintenance-related issues. And finally, there are many ways to build an action plan while doing a reliability assessment. Lots of pillars to look at. And in this reliability roadmap, we're going to look at some very important pillars, like asset master data in your CMMS, your planning and scheduling process, your inventory management practices. Once you've established the gap between where you are today and where you want to be a few years from now it's easy to build your action plan. A very important step while building this action plan is to prioritize properly and include all your stakeholders with you. Make sure that they are aware of the priorities and they build them with you so that no one is surprised at the end of the day. Several studies show that 50 to 80% of the lifecycle cost of industrial assets is spent while operating and maintaining pieces of equipment. Now, in our objective to spend money, effort, and resources at the right place at the right time, we must shift that big chunk of resources and put it at the design phase. That means that from the get-go, you must select the proper parts and components for your asset that will meet the requirements for performance. You may have a very difficult production environment with lots of humidity, moisture, contamination, etc. Select the proper parts and components that will resist to this harsh environment. Also, make sure that your new piece of equipment, your new line of production is designed to ease up maintainability and inspection. Also, make sure that your assets are designed so that your technicians and your millwrights can easily inspect them. Look for oil leaks, issues, and whatnot. And finally, before commissioning, make sure that you build your whole asset master data, bills of materials, criticality ranking, and the proper standard operating procedures, PM tasks, loop tasks, etc. That way, you will be off to a good start. One of the key elements of our roadmap is the CMMS master data. It is everything that resides within your computerized maintenance management system. We start with a hierarchy. You must make sure that all the assets in the field reside within your CMMS. To build that asset hierarchy, you need a standard like ISO 14224. It will help you build a complete and accurate asset master equipment list. Now, another key element is the bills of materials, the BOMs. Those BOMs are all the spare parts needed to complete either preventive maintenance activities or reactive work. Those BOMs must be precise, complete, and accurate. Also, something that is highly important is that you make sure that all of your parts are properly coded within your CMMS. That will prevent having duplicate entries, especially when you have multiple OEMs who provide you with multiple parts lists that in end will have a big impact on your storage, your cost, and of course the reliability of your program. So now you have your asset hierarchy that is built. You must now ask yourself, what are the most critical pieces of equipment in this hierarchy? Let's take an example. You go to your boiling area and you ask your production manager there, what is the most critical piece of equipment of our facility? He will surely answer you, well, it's the boiler, of course. Now you go to another area in your facility, for example, paper machine, and you ask the same question to the area supervisor. It's going to tell you, well, it's the couch roller or the drying area. None of these two people are right or wrong. They are right and wrong at the same time. It's just their subjectivity and emotion talking. What we want to achieve with criticality ranking is to take emotion out of the equation and replace that with objective criteria. So we've listed 5 criteria for running a criticality ranking exercise. The first one would be the impact on safety. Think about the most probable and most catastrophic scenario where a piece of equipment would fail unexpectedly and maybe injure or even kill worker or workers. The second criteria would be environment impact. Think about a reservoir that might leak and spill hundreds of gallons of contaminated product into a river. The third criteria would be the impact on production. Think about a piece of equipment that would fail unexpectedly and probably shut down production for hours or even days. Now, the fourth criteria would be impact on maintenance. Think about, do I have all the resources needed to fix an equipment right away? All the spare parts? What is the lead time on some of these spare parts? And finally, would be the impact on quality. Think about a metal detector that would fail unexpectedly. You might end up with chips of metals in cookies or milk or French fries, and that would result on a very bad crisis for you in the media or in the public. So these are the 5 criteria to take into account when running a criticality ranking exercise. So in the previous step, we've talked about the criticality ranking of your assets. Now that you know what are your most critical pieces of equipment, you must build your maintenance strategy based on that criticality ranking. We need to do the right task at the right time, by the right person, the right way. What we like to do is to go at the failure mode level when doing that exercise. What does it mean? It means that we must list for all of our components what are the symptoms of upcoming failures. Take a motor, for example. It may overheat, or it may vibrate, or it may make strange noises. These are the symptoms of something's happening with a motor. And now you're going to address those failure modes with specific tasks at a specific frequency. For example, for the leaking failure mode, you might decide to do a visual inspection every week or every 2 weeks or every day made by an operator. An operator will check the oil level on that piece of equipment, and so on and so forth. So this is the best way to build a strong maintenance strategy and really focus your efforts on what's important. So you've built your maintenance strategy. You know what tasks to do, at what time, by whom, and the right way. Now you must make sure that your maintenance workforce is properly trained to execute that maintenance strategy. For example, you may have decided that instead of replacing all drive belts every 6 months, you're now going to do a deflection inspection every 3 months. Now, how do you make sure that your workforce is properly trained to do so? It is a complete shift from what they were doing previously. So you must make sure that they are able to execute that maintenance strategy. Most importantly, not only they must be able to be ready to execute the maintenance strategy today, but we feel that it's even more important that they have a workflow of evolution through time, a complete pathway for their whole career. Where am I going to be 3 years from now, 5 years from now, 10 years from now? Maybe some of your millwrights wants to evolve in more reliability technician role, being certified in vibration analysis, for example, or certified in infrared camera capturing. So it's very important that you build those pathways for all of the roles in your organization, from the millwright to the planner and scheduler, supervisors, managers, and even your plant manager. So we have our workforce that is properly trained, and we have our maintenance strategy that is defined at this point. We get to the work management process, which is really about executing the work. There are 6 steps in this process. First step is the work identification. Our maintenance strategy has defined routine inspection rounds. So you would have one of your technicians go out in the field and do visual inspections. At some point, he will probably find an issue, for example, a leak on the reservoir. What he's going to do is that he's going to create a work request or a work order within the CMMS. That work request will have to be prioritized in order to be put into the backlog for the planner. Step 2 is planning. In the planning section, the planner takes the work order and does a bunch of things. What is very important to do is to estimate the level of effort. How much time is this job going to take? Remember, we're talking about replacing a seal on a gearbox. So the planner will estimate 2 to 4 hours of work. He will estimate that a millwright will be needed for these 2 to 4 hours. Maybe an electrician might be needed to lock out and tag out the asset. Also, the planner will look at the bills of materials, order and reserve parts for that specific jobs. Also, the planner might request for specific tools like a lift, for example, that could be needed to execute the job. Once the planning step is done and the job is planned, we get to step 3, which is the scheduling part. Now, the scheduling part is often done by a scheduler or a maintenance supervisor. The scheduler will coordinate with production to assess what is the best time to execute that job. Remember, we're talking about seal replacement, so we need the asset to be shut down. So we'll look at the production calendar and look, all right, next Saturday, we have a production shutdown for 8 hours. That might be the best time to execute that job. Also, the scheduler will look at the workforce calendar and say, okay, we're going to use Bob that day. He's available, he's not on vacation, and he is the most suited to execute the work. Now, the Saturday comes and we get to step 4, which is the execution. Bob is going to take the work order, take the parts, go on the field, lock out, tag out the equipment, replace the seal, and production will start back. What Bob will do also is he will write feedback on the work order. He's going to say to the planner, for example, hey, I didn't have enough time to properly do that job. Or he might say that he didn't have the right parts, and all of this feedback will enable the planner to do a better job for the next seal replacement work that will be done. Now, the last step is the follow-up. Remember, we had originally a maintenance technician who went for a routine inspection round in the field. He found a leak, but in the end, the leak was fixed. So it highlights 2 things in this process. First, the maintenance strategy is efficient because we said a maintenance technician would go in the field and find leaks. The other important aspect is that we find a problem and we efficiently fixed it with our planning and scheduling process. We were able to find the right person to do the job, find the right parts, and repair before the full asset shut down because of a lack of lubricant. So that's the work management process. Now, of course, there are unexpected breakdowns. And when that happens, a catastrophic failure happens, of course, planning and scheduling is bypassed and we go direct to repair. So we've got our maintenance strategy that is executed through our work management process. Now, this is going to generate tons of data. Think about your vibration program, for example. Every 30 days, a technician is identifying potential issues related to misalignment or bearing failures. Think about your oil analysis program. You're doing routine sampling on reservoirs to identify problems like contamination or degradation. Think about your operator rounds. Think about your millwrights rounds. Think about your IR rounds on electrical components or even rotative components. So all of these are silos of data that don't necessarily communicate with each other. Your Vibe Tech probably will send you a PDF report. Your oil lab will also send you another PDF report. Now, what happens if you have issues on the same piece of equipment? How can you make sense of all of this data? Let me give you an example that I saw recently. A vibration technician identified a potential bearing failure on a pump. At the same time, the oil analysis sample revealed that water was in the crankcase. In the end, it was the oil analysis that was right. Actually, what happened is that the Vibe Tech was confused in terms of frequencies between the bearing failure and water presence. That finding, because of a comprehensive asset health view, enabled our customer to save thousands of dollars in repairs. So this is why asset health is extremely important. It will help you make better decisions faster. So we've seen that with our work management process, we are reserving parts and consuming spare parts. Now, it could be very important to optimize our inventory based on our parts consumption. To do so, we must do criticality ranking of the parts. As we've seen it before, we can do the criticality ranking of assets, but for the parts, it's a little bit different. The criteria that we're going to use are going to be the following. First, we're going to look at the lead time. The longer the lead time, the higher the criticality. Same thing for the cost. Also, you're going to look at if a part fails, what is going to be the impact on your production. Also, you must look at the detectability of a failure mode on a specific part. Is it an electric component that will give you no clue that it's about to fail? Basically, it's going to run and then it's going to fail. In that case, you must have that part in stock when it fails so you can repair as fast as possible. So once you've done your criticality ranking, you're going to use that to define your service levels. Service levels are the following. What is the probability that I'm going to have a part in stock when I need it? For the most critical ones, you want 99.999% chances that it is actually in stock when you need it. And so on and so forth, based on the different criticality levels. Once you have your service levels that are defined, it is now time to optimize the safety stock and the min and max levels. That will adjust your whole inventory based on the consumption and based on the criticality ranking. Again, our objective with that step is to focus our efforts on what matters the most. So we've seen that with our maintenance and reliability program and our work management process, we're going to generate a ton of work. And sometimes we're going to have unexpected failures. Most of the time, we hope that it's minor failure, but sometimes it's major or catastrophic failures that shut down production for hours or maybe even injure our workforce. In that case, having a good defect elimination process in place might become super important for you guys. Root cause analysis can be done through multiple ways. Ishikawa, it can be a 5Y, or other recipes. The important thing when doing an RCA analysis is that to find the root cause issues that led to the failure, but most importantly, is to put in place actions to make sure that these problems never happen again. This is often where we see problems in organizations. We identify the root cause issues, but we never fix them for the long term. Also, what's very important in the defect elimination process is to have automatic data, statistic, graphs that come from your CMMS or your APM software. Data such as the bad actors that eat your lunch every day, or what are the most encountered failure modes related to vibration or oil analysis or visual inspection. This data can help you improve your maintenance and reliability program for the long run. So at the beginning of the journey, we talked about our vision. And to achieve our objectives, we need a way to measure ourselves. And this is done through the KPIs. There are tons that exist, especially for the maintenance and reliability world, The most important thing is that you choose the ones that fit the most your reality. Now remember, there are two types of indicators, the leading and the lagging. The lagging indicators are indicators that tell you how good you've done in the past, and the leading are indicators that tell you how good you will do in the future. To give you an example, availability of your assets is typically a lagging indicator because it tells you how much availability you've had for the past week, month, or year. When it comes to PM compliance, on the other hand, this is a very good leading indicator because how good you've done with your preventive maintenance program will tell how good you're going to be in the future. So again, choose the right KPIs that are in line with your objectives, the ones that fit with your vision and the ones that will reveal if you are on track to achieve your objectives or off track. So we're at the end of our journey, and that last step is probably the most important of all. It is the leadership. It is actually the step that supports all of the other pieces of the puzzle that we've seen. Leadership is about making sure that we have one team that has integrity, that has one goal, and that aims for that objective and that vision that we've established in the beginning. Think about optimizing your maintenance strategy, for example. We've said that this could include lots of changes in the way we do things, right? New ways of doing, new trainings required, and in the end, a lot of management of change that is involved in that step. Also, think about the sustainability aspect that we talked about in the beginning that will completely revolutionize the way we produce things, the way we produce goods, the way we have energy supply. So leadership is really the cornerstone of our maintenance and reliability excellence project.